Hello guys, welcome to BYJU'S Exam Prep, the most comprehensive preparation app for all the competitive exams. So today I am going to discuss what are the basics required for understanding theory of competition. I will also teach you the basics here. Okay, so please confirm me once whether my audio, video, everything is clear. Am I audible? Just confirm me once. Is my audio, video, everything is clear? Yes, okay. I once again welcome you all to my session. So, in theory of computation, I have started yesterday, and in yesterday, so what are the things required for theory of computation? I told you. Now, here today, for understanding all the concepts of theory of computation, what are the basics required? In today's session, we will discuss. So, join quickly and mark your presence, and please do share the session with your friends, and also please. Just subscribe the channel if you are not yet done the subscription. Okay, yes, so shall I start the session? So just you can say hi or hello. Yes, okay, say something. Okay, so you can use the chat box for asking your questions on the theory of computation. Okay, so now let me start the session. Before I begin, so let me introduce myself Murali Krishna Bokkasamudram. I am having 21 plus years of teaching experience both in the GATE and also I worked in different engineering colleges, and I am topper of NPTEL course in theory of computation. So that is what I am teaching you right now, and I am certified as international engineering educator through ISIP certification program, and I have mentored more than 50,000 students across the country in different core areas of computer science and engineering. Those are theory of computation TOC, operating systems OS, computer organization and architecture COA, computer networks CN, digital logic and design DLD, and information and communication technology ICT. Okay, so shall I begin the session? Is my audio, video, everything is clear? Just you can say hi or hello in the chat box so that I will understand if people are following. Okay, na? So now let me begin the session. And before that, I wanted to give you some important information. So we are starting GATE Rankers Monsoon series. It's a free course in the YouTube. Most important topics will be covered. So that is in electrical, electronics, and computer science. It will be started from 10th July onwards. All these faculty will teach you some important topics for the GATE. Okay. And there is a workshop on. It's a free live interactive workshop by Dheera Sadhana sir and Abhinav Regi sir together. Or just the topic of the workshop is: are 7 months enough to get all India rank under 100 in the GATE? So this is on 2nd July. So it is on Sunday at 12 noon. So please don't forget to attend this session and try to make use of this. Okay. And now let us start the session. So basics, actually what basics are required for understanding the subject? One has to know what is an alphabet and what are the strings. So usually a finite non-empty set sigma of symbols called the alphabet. Example, an alphabet with 3 symbols is like sigma is equal to a comma b comma c. Usually all the languages what you are defining will be defined from the alphabets only. Language is nothing but some collection of strings. The strings are defined over some alphabet, and alphabet is containing characters defined in some notation. Like character may be alphabets from A to Z English alphabet, or it may be special characters like hash, okay, dollar, left parenthesis, right parenthesis, full stop, comma. All the keyboard symbols we use can be used as a terminal symbols or alphabet symbols. Okay, and string is nothing but strings are finite sequences of symbols from the alphabet actually. For example, if the alphabet sigma is equal to a comma b comma c, then AB is a string and AAA BBC is a string defined over the same alphabet. Hope everybody is following. Okay, am I audible? Can somebody confirm me once? Is my audio, video, everything is clear? And before you just go through that, please share this class information with your friends, and also you can do subscribe the channel. Okay, so now let's move on to the next slide. Hope I'm visible and audible to every one of you. Okay, so this class is very important in so that if you understand some few basics, it is very easy to understand the subject theory of computation. So that's what I am teaching you right now. Now coming to alphabets and strings continuation. So the length of the string, for example, if you take W is a string, so length of the string is denoted by modulus of W, and is the number of symbols in the string is nothing but length. So W is equal to AB, then the length of the string modulus of W is equal to 4. For example, if X is a string defined with A, B, C, D, so modulus of X is nothing but length of the string, it is equal to 4. And we can perform different operations also on a string, like, so null string or empty string is a string with no symbols whose length is 0, and it is denoted by the symbol epsilon or lambda, and some textbooks will follow cap also. If any symbol is like epsilon or lambda and cap, so these three symbols are similar whose length is 0. These are the strings whose length is 0. That is nothing but null string. String whose length is 0 is nothing but a null string. String whose length is 0 is a null string, or we can say empty string. Okay, so we can perform different operations are also on the string, and you have to cover the type of operations you are performing on the strings, and you have to cover the type of operations you are performing in the languages, and you have to cover in the basics different types of languages analysis. Okay, and what are valid strings, what are invalid strings in a language. That is the most important point of the formal languages and automata theory. The reason for that is, so in the coming chapters we are going to learn about designing of machines for the languages, or designing of grammars for the languages. If you do not know what are the valid strings in a language as per the definition given, and what are the invalid strings, it is very difficult to construct the abstract machines, or you can say grammars. Okay, so that's the reason one should understand in detail the validity of strings in a language. That is the most important, and also the different notations we use for representing a language also important. Different textbooks will follow different notations. So that's why actually the by and large this subject is named as the formal languages and automata theory. Formal languages and automata theory. So language theory, for every language you have to analyze what is a grammar and what is a machine, and what is a regular language, what is not regular, what is a context free, what is not context free, all those things. Okay, so if you can visualize this entire concepts in abstract way, then keeping in view of this, you can go with the topics one by one. Okay, so please do share the class information with your friends, and also please do like this session if you are really liking it, and do subscribe the channel, please. Okay, now I will move under this. What is the length of the epsilon? It's 0, and epsilon dot any string or any string dot epsilon is equal to W. For example, W is a string, and epsilon is preceded by W or succeeded by W, so it is W only. It holds true for all W. So simple. For example, if A, B, C, D is a string, for example, and epsilon is a prefix, A is a prefix, AB is a prefix, and ABC is a prefix, and ABCD, these are all prefixes. And epsilon can be either preceded by the symbol or succeeded by the symbol. Or if you write something like A epsilon B, and in the concatenation we can write it as AB. Okay. So null string has got its own importance in the theory of computation for theoretically to prove certain things. But finally, we don't implement the null strings, and we will remove those null strings in appropriate places, and we will implement the machines. Okay. Now coming to a formal language. What do you mean by a formal language? And see, for example, in the world, people will speak the formal language. Most of the people, like for example, English is a formal language. Hindi is a formal language. When can you say that a language is a formal? Because if it has a formal alphabet, it has a formal grammar and framing the sentences, everything. But in India, there are so many languages, some tribal languages, which is not having a grammar, no script also, no alphabet also. So that type of languages are not formal languages. Here, these languages which we are defining here for making a computer to understand. English, Hindi, Telugu, these languages are for human being to speak. Okay, but these formal languages what we are studying is for a machine to understand. Okay, like regular languages, contextual languages, context sensitive, etc. Okay, so a formal language is an abstraction of general characteristics of a programming languages. Okay, which we are using in the computer. A formal language consists of set of symbols and some rules of formation by which these symbols can be combined into entities called sentences. So language is nothing but some collection of sentences. Okay, and also a formal language is set of all sentences permitted by its rule of information. So some conditions will be there. So like defined differently for different types of languages based on alphabet and conditions. So grammar is nothing but the way we are producing the sentences. We have to represent formally. So in the previous class also I have told you a grammar is shown with four entities. Grammar abstractions called variables, and grammar for alphabets are called terminals, and rules are called productions. And from the starting symbol, every sentence we have to derive. Okay, so it's a finite set of production rules you have to follow. And examples of formal language is very, very important throughout our topics. And we are going to analyze the formal languages and automata theory. What is a language and what is automata? So for regular languages, how to construct finite automata. For a context-free languages, how to construct push-down automata. So like this. So language is some collection of sentences with some predefined meaning. For example, if we take L1 is equal to A power n, B power n. Alphabet for this language is A comma B. And the meaning of the sentences here is followed by same B's. And AB is valid string. AABB is valid string. If you construct a grammar or you construct a machine for this, you should accept only the valid strings. Invalid string should not be accepted. Valid string should not be missed. Invalid string should not be accepted. So that's why correct pattern is required. So that's why we need to analyze the languages, because there are a lot of notations followed in different textbooks in different material. So if you can get the essence of all those textbooks, so that any type of question, any type of notation given in the examination, it is very easy for you to grasp the things. Okay, now coming to some languages, a power 2i, I greater than or equal to 0. So if I value 0, we can get 0 instance is epsilon. If I value 1, you will get 2 a's. If I value 2, you will get 4 a's. If I value 3, you will get 6 a's. Like this, number of a's will come. Even number of a's will come. So this is what language L2. Okay, and also language L3, WC W power R. This is a new notation. And W is 0, 1 whole star, means it is a word of zeros and ones. So alphabet for this is, in addition to 0 and 1, there is one constant C also. And W power R is reverse of W. Okay, so what are the strings present here? If W is a null string, so we can have C is a minimum string. And if W is 0, its reverse also 0. If W is 1, reverse is also 1. If W is 1, 0, reverse is 0, 1. If W is 0, 1, reverse is 1, 0. If W is 1, 0, 0, reverse is 0, 0, 1. So this type of strings present. For example, if we take a string, something like 10C 0, 0, it is invalid because 0, 0 is not a reverse of 1, 1. So only valid strings we will consider. Okay, and if you construct a machine or you construct a grammar, and only valid strings should be accepted without missing, all invalid strings should be rejected. So that is the prime goal here. So that's the reason for the theory of computation, to understand better way formal language and automata theory, you should have knowledge about languages and its valid string and invalid strings. That is the first and foremost thing. Okay, for example, for an A power n, B power n, if I construct a machine, and A power n, B power n strings only should accept without missing any of the string. But no string. For example, if I take invalid string BA, it should not accept, and AAB, it should not accept. More A's than B's. ABB, it should not accept for this language. Okay, and here also, for example, if I have 3 A's, it should not accept because it is even number of A's. Okay, now coming to, I hope you people are understanding this point is very, very valid and important point for understanding this theory of computation. Please. And please do share the class information with your friends, this important information. And also, if you take another language L4, A power I, B power J, this is J. A power I, B power J, and I value greater than or equal to 1, J value greater than or equal to 0. So minimum string is A, because B power 0 is nothing but epsilon. So A will come when I value 1, J value 0. When I value 1, J value 1, AB also will come. When I value 2, J value 0, AA will come. And ABB, I value 1, J value 2. Okay, and this type of strings are possible here. Only A's, any number of A's when B is 0. This type of strings are possible for L4. And any other is invalid. Okay, something like, for example, single B is invalid here. And ABA is invalid because after B, A will not come. So this type of pattern recognition is very important. and this is L4, L5, and a lot of languages, hundreds of languages you have to analyze for understanding the patterns, valid patterns and invalid patterns. Okay, then only either grammar you can try, or you can try the abstract machine like finite automata, push down automata, Turing machine, etc. And here, what is alphabet for this language? Alphabet sigma is equal to 0, comma 1, comma 2. So n number of zeros followed by m number of ones followed by 2's are n plus m. So n and m greater than or equal to 1. Okay. Now coming to valid strings here. For example, minimum value of n and m is 1, 0, 1, and 1 plus 1, 2 2's will come. If I take n value 2 and n value 1 and 3 2's will come. N value 1, m value 3, then you will get 4 2's. So like that, you can get the strings 0 power n, 1 power m, 2 power n plus m. Okay, and this is a pattern. And also, if you take L6, a power p such that p is prime, so prime numbers. So alphabet for this is only a, input alphabet, but strings are 2 is a minimum prime number. Okay, now 3 is the next minimum prime number. Next 5 is 5 is a prime number. Next 7 is okay, is a prime number, like this. Only prime number of years we will consider. Alphabet for this is equal to only single A. Hope you are following. Okay, am I audible and visible to every one of you? Please confirm me once. Okay, now coming to some more examples. So L7, A power I, B power J, C power J, D power I. I value start with 1, J value start with 1. So what is alphabet for this? Sigma is equal to A comma B comma C comma D. So for every A, D is required. For every B, C is required. So B's and C's are equal. A's and D's are equal. And the pattern is A's followed by B's followed by C's followed by D's. So the smallest string we can have is A, B, C, D, where I value 1, J value 1. When I value 2, J value 1, A, B, C, D, D. When I value 1, J value 2, A, B, B, C, C, D. Okay, and A, B, B, C, C, D, D also possible. And we can have A, B, C, D, D, D also possible. So this type of strings are possible here. Okay, now these are the examples of different formal languages. And L8 is equal to A power I square, I is integer. If I value is 1, we can have 1 square means 1A. If I value 2, we can have 4 A's. I value 3, we can have 9 A's. Okay, I value 4, 16 A's, like this. So for this also alphabet is, it's a perfect square. Number of A's are perfect square here. And similarly, if you take L9, A power I, B power 2J plus 1. Can you tell me what are the minimum string here? Can anybody respond and tell me? Nobody's responded here so far. Just respond. What are the minimum string here? Am I audible and visible to every one of you? Yes. Okay, fine. Yes, you can initiate the chat once. Okay, so fine now. A power I, B power 2J plus 1. Hi, Akhil Gaud. Yeah, smallest string is not A. I'm sorry, Akhil Gaud, because I value start with 1, J value 0 means 2J plus 1. 2J plus 1 means 2 into 0 plus 1, 1B will come. AB is a minimum string. And I value 1, J value still 0, for example, AAB. I value 2. I value 3, triple AB also possible. And if I take I value 1 and J value also 1, J value 1 means 3B's will come. And I value 1, J value 2 means 5B's will come. So like this, even 2 A's followed by 3 B's, 1 or more A's followed by odd number of B's. 1 or more A's followed by odd number of B's. Okay, na? So A's are independent here. So there is no dependency in the sentences. There is no dependency in the sentences. Okay. So like that, validity of string in a language is very important, because if I construct a grammar for this, all those sentences must be derived from the starting symbol through the productions, and wrong strings should not be generated. For example, ABB is a wrong string because even number of B's are not possible. Okay, hope Everybody understood this? Okay, now let us move on to the next sentence. L10 is equal to W power R, such that W is a string of zeros and ones and W power R is reverse of W. So what do you mean by reverse of W? Tell me. So minimum string is epsilon. Earlier there was a C in between, WC, W power R. So here both are direct. So even length palindromes. Epsilon and 0 0 possible, 1 1 possible, 1 0 0 1 possible, 1 1 1 1 possible, 0 1 1 0 possible, 1 0 0 0 0 1 possible, and 1 1 0 0 1 1 possible. So this type of strings are possible. A word followed by its reverse. It's an even length palindromes. What do you mean by palindrome? What do you mean by palindrome? Palindrome is nothing but a string reading same from left to right and also right to left. For example, I am reading like 110011. Right to left also reading same 11001. That is what palindrome is. Okay, now? Is it clear? Okay. Yes. Yes, Gautami, Maheshwari. Thank you for your response. Now coming to next one. This language you can observe. This language, what happens is, what happens here? A power I. What type of strings are valid here? Tell me. Can tell some of the valid strings. So A power I, B power J, C power I, D power J. So A's and C's must be same, B's and D's must be same. So the smallest string is A, B, C, D. And we can also have A, B, C, C, D. We can also have A, B, B, C, D, D. This type of strings are possible. Okay, na? And L12. A power 3I, B power I, B power J, sorry, this is J, B power J, I greater than or equal to 0, J greater than or equal to 1. If I value 0, for example, 3 into 0, 0 only, J value 1 means 1B possible, J value 2, 2B is possible, J value 3, 3B is possible, still I value 0. And I value 1 means we can have 3A's followed by 1B, or 3A's followed by 2B's, and 6A's, like that it will come. Okay, na? And these are the strings, and this is basically number of A's multiple of 3 followed by any number of B's, one or more B's. And L13, so like that, so many languages you have to analyze. And L13, X strings like X, where X is a combination of A's and B's. N suffix A of X mod 3 0 means number of A's present in every string should be multiple of 3. And they did not mention anything about B's. That means there is no restriction on B's. Any number of B's are possible. Okay. So number of A's multiple of 3. So epsilon is possible because A's are 0. 0 is a multiple of 3. Single B, double B, triple B, any number of B's you take, but number of A's are 0 only. And you can take A, B, A, number of A's 3. You should accept. And A, B, B, A also should accept. And A, B, A should accept. A, B should accept. B, A should accept. And also A, B, B, A. 6 years also can accept. So this type of strings can be acceptable. And L14 you see, A power N, B power N, C power N, N greater than or equal to 1. What does it mean? What is alphabet for this? Alphabet sigma is equal to A comma B comma C for L14. And A is followed by same number of B's followed by same number of C's. So we can have A, B, C, A, B, B, C, C, triple A followed by triple B followed by triple C. So this type of strings are possible. Okay, na? Any doubt? Yes, Gautami, tell me if you have any doubt. Okay, shall I go ahead with different examples? And what about this? 0 power n, 2 power n, and this is 3 actually. 0 power n, 2 power m, 3 power k, n is equal to k, and m greater than or equal to 0. 0, 2, 3 are the alphabet. So alphabet for this is 0, 2, 3 are the symbols. 0, 2, and 3 are the input alphabet. And n is equal to k. So 0s and 3s must be same. M value can be 0 also. So 0, 3 possible, 0 0 3 3 when n is equal to k is equal to 2, and when n is equal to k means n value k value, if nothing is defined means minimum 0 also we can take. M value 1, n value k value 0 also we can get single 2, and 0 2 3 also possible, 0 2 2 3 also possible, 0 0 2 3 3, but only condition is number of zeros, number of threes must be same. In between 0 or more 2's are possible. Okay, now L16. So x says that x is strings of zeros and ones, and modulus of x mod 3 not equal to 0 means string length should not be multiple of 3. So string length should not be multiple of 3 means epsilon not possible. So single 0 possible, single 1 possible, length 1 acceptable, length 2 acceptable. Okay, and length 3 should not accept. Length 4 can be acceptable. Okay, length for any string like this strings can be acceptable. And AB whole power I is equal to k. For every AB instance, C should come. So ABC, and I value 2 means AB you have to write twice and CC, and I value 3 means AB thrice k means 3 C's must come because there is a dependency here. And L8 W, these are done, right? W is a string of A's and B's and C's. Number of A's of W must be equal to number of B's, and C's can be any number. So accordingly we can give strings, and you can just practice these questions also, like L19, L20, L21. I am giving you as a homework. Just you can take a screenshot, or later on you can see the video and check these problems, and you can take a homework, and you can just ask me if you have any doubt in the comment box. Okay, L22, L23 also. Just this is given as homework just for analyzing what are valid strings and what are invalid strings. So till L24 I am giving you, and please make a comment in the comment box for asking any question related to this. L25 also. Okay, 26 also, 27. So these are the strings. Okay, so that's all for today. I hope everybody have enjoyed the session, and please do attend the tomorrow session also, and how to write a regular expression and all I will tell you. And please attend the classes regularly at 10:15 daily. Okay, so thank you so much. Thank you, Anadal, and wish you all the best. And please do subscribe the channel if you are not yet done it, and please also do share with your friends. Thanks a lot. Bye bye. See you. Good night.